Now that we have created the block design and generated the bit stream and exported it, now we are ready to program our ARM processor using Vivado SDK. So for that, if you have exported the hardware, just click on launch SDK and click on OK. It will automatically launch the SDK. Okay. Now that this has been created, uh, let's just um, let's just create a new application project. Since I'm writing my code in C++, I'm going to select C++. And if you're writing your code in C, you need to select C. First, let's just create a project here. Mine will be project. And go to F. So, next, empty application. Great. So, let's see. Okay. Now that we have created a new application, we need to first check whether the library, whether the IP that we have, IP code is integrated with the SDK. Yep. So it was not loading properly. So yeah, to see whether the IP has been integrated with the SDK or not, we need to go to Cordic lab f underscore PSP and then go to include and search for your IP, search for the name of a top function. Now it won't be the exact name, it would be like this X Cordic, so the top function, and there would be an X concatenated with it at the beginning. So this is basically my IP that I integrated with that I created the block design and then exported it to the SDK. So yeah, the previous things that we have done are successful. So there will be a crucial difference if you are using if you are if you are writing your code in C++ or in C. If you are writing your code in C, then you can directly proceed and you can skip the following steps that I'm going to do. But if you're writing your code in C++, there are certain libraries and certain header files that you need to include which are not given over here. So for including those header files, you need to create another application project. Now this application project will be in C, so just give it a random name. So I'm going to give it this name. And this project library is not necessary. So this application project is not necessary. You can delete it later also. Just go there and make sure it is selected hello world and then finish. So there are yeah, here it is. Now go to the Cordic test underscore UU, application project that you have made using C in C language. Now these three platform underscore config platform.c and platform.h. These three files are very important and we need to include them in our original and our actual application project. Just copy paste them. Okay, now that we have copy pasted it, make sure that these are correct and yeah. Okay, so these are working fine. I think now the Cordic test underscore UU is not necessary, so you can just the delete project control. You can just delete this project application. These are not necessary, but make sure you don't delete the Cordic underscore lab underscore F, the actual one. Okay, so now that the initial preparation is done, from this onwards, the both we will proceed. There will be the same process for both C and C++ language. You just need to make some minor changes in the code. as I'm writing in C++. So we have provided you the code in the lab handout. So it is advisable to go through that code. These are the libraries. So, so these are the libraries that we're using. And you need to make sure that the in, while I was testing and making the handout, I used Cordic 4 as the name of the top function. Thus, I'm including xcordic4.h header file and xcordic4 underscore hw dot h header hw header file. But here the name of the header files that we saw were as such xcordic underscore hw. So we need to just uh, update those. And yeah, now this is perfectly fine. Now there are a lot more warnings. You will also face the same warnings that I am facing right now. The best way to clarify these warnings, best way to fix this is to open the Cordic and xcordic.h and xcordic.hw. So yeah, the best way to deal with this problem. So yeah, the best way to deal with this problem is to just make sure that you give it a correct name. Give it the correct name that you are seeing over here. As it is xcordic, it should also be the same. Okay, so I have changed. I have corrected the name. And if you're not sure what the correct name of this, like here you can see that we are the name of this is xcordic underscore set underscore theta. It was initially xcordic 4 underscore set underscore theta. So if you're not sure what the actual name is, you can just go to xcordic h and search for the actual name. As you can see here that we have xcordic underscore set underscore theta. So this should be the name that we are using in the main.cc or the hello world.c. I will provide you with a brief overview of this code, but for in-depth knowledge of how this code works, you can always refer to the Vivado HLS training that we have linked to the training that we have provided you. So in the HLS Cordic lab, as you can see, this link will take you to our HLS course training, and then video number 5, the trainer has provided you with a brief, with a in-depth knowledge of how to write this code and how to generate a Vivado HLS IP code. So yeah, I'm also referring to this code for certain functions. So the basic thought process behind this code is that we need to initialize and configure the the IP code generated. So this part of the highlighted code does the same thing. It initializes and configures the IP code, and this part always remains the same no matter what kind of IP we have generated, as long as the basic structure that we have used remains the same. So next we are calculating the sine theta using PS part of the Zynq code. So we are using the PS part by using this function that we are written over here. So the function is written over here, and it is just a bare bones Cordic algorithm. It takes a parameter theta and returns a value, and also include. As you can see, there are no fixed there is no EP fix library used over here, and there is no fix, and we have not implemented any optimization over here. This is just a bare bone unoptimized Cordic algorithm. Next, we are going to calculate sine theta using the above shown function. Calculate the time it requires to implement that algorithm by the processor. And we're going to do the same thing with the hardware. So first we need to initialize the parameter that we're going to provide to the hardware. The value sine theta, we initialize it with 60 degrees, as we need to calculate the value of 60 degrees, and we are making sure that we set the value of 60 degree to our hardware. You can see that you can find these type of variables from over here. As you can see that this is this is an inbuilt function that sets the value of theta to the hardware into the hardware. Now we need to make sure that it is provided us that this is a type defined of U32. So basically this is an IEEE format for of single representation. But we have written here of in float. So we need to convert this float value into a U32 data type. So for that conversion we are using this function over here. Basically what this function does is basically it converts the float data type to IEEE single representation 32-bit data type. And similarly we are also using this function which is U32 float, so that when we receive the result in U32-bit in U32 format, we convert it back to float for us to analyze the output and for us to check whether the output is correct or not. So similar from the PS part, we have also used this expression to calculate the time it takes to for the hardware to calculate the time it takes for the hardware to calculate the sine theta for the theta that we have provided. So now that this part is done, we're going to save this and let's first modify the if so this part depends on whether you have the Zybo Z10 board or the board at your disposal at hand or not. Now currently I don't have the board with me. I'm using I will use JTAG terminal and I will use the hardware server to connect to the board which is in the institute. So for that I need to modify the BSP settings. We need to go to standalone. And over here we need to change the standard in and standard out. So if you are using if you have the board at your disposal and you have the board and you're connecting the board using the universal serial bus or the USB, you can skip this part. But if you are using the board as an online medium, they're using JTAG terminal to give standard input and standard output, you need to make sure that you do this. You need to make sure that you change the standard out values. So you need to change it to core site comp _0. So after this is done, just regenerate from USB settings. After this is done, we need to connect the board. We need to connect our system with the board. So for that we need to add a target connection. So I will use the Zybo office. And as default target, use single server. So now we're going to write the host. So this is the host IP of the host that we're using, and the port is the same. Oh, before that, you need to make sure that you are connected to the FortiClient client. So after connecting to the FortiClient client, I'm just testing whether the connection is successfully established or not. So yeah, it's okay. So now let's debug this code, or we can run this code directly. Yeah. Right click on the Cordic library and debug as. Go to debug configurations and double click on over here. So yeah. Now you need to click, make sure that you take program FPGA. So I click program, click on apply. That apply and then you debug this. So you can see it is processing over here. You need to wait until this process is open. Now here we can see that we have successfully established connection with the hardware. First let's just open the JTAG terminal. Now that we open the JTAG terminal, let's just run resume this process and see what outputs we get. This we use, so basically we use data terminal for processing, for giving the processor inputs as well as outputs. Here we are only receiving output using printf, but you can see that we can also give it certain inputs, like we can provide it with certain values of theta by using scanf. So you can implement that part of the code on your own, and that concludes this project.